So today, class, we're going to be doing a bunch of questions about loops over strings. I collected them from past assignments and your exams. The first one we're going to do today is contains digits. Let's continue. Bruh. Okay, so we're going to take contains digits, take C's, which is a string, and it's going to return a Boolean. Okay. So I'm going to write this mathematically, right? Checks if there exists C in C's such that C is a digit, okay? And what were our examples? Sort of contains digits 1, 2, 3. That was false. Contains digits. Okay, 1 to go. I don't know. True. Okay, so this should be a fairly straightforward one. How can we do this? All right, so first I need to loop through. I need to check each individual character in the string. And what should my exit condition be here? Right, what am I searching for? I'm searching if any of these C's happens to be a digit. And if one of them happened to be a digit, what do I do? Return true. So I want to return true in this loop, false otherwise. And I want to return true when? Well, if C is a digit, so I can write it like this, is digits. And I forget if it's is digit or is digits. With an S? Okay. So I can say if C is digits, return true, else false. Let's give this a go. 1, 2, 3. Just going to call this into Python. Contains digits. 1, 2, 3. What happened? Okay, so maybe it's not is digits. Yep, it's is digits. Right. So don't be too worried about remembering these built-ins. On your exam, on the back page, we list all of them. All the built-ins are listed there for you, along with what they do. So memorizing is not a valid strategy for this course, because it's not required. Contains digits, okay, 1 to go. Should be true. Perfect. Okay, so I'm going to modify this a bit to remove this built-in command, right? Just in case. I like making things more explicit, just so we can see how the computer is operating. So instead of checking if C is a digit, I can check if C falls in between the digit 9 and the digit 0, right? Right, as a string. Right, so this will check the same condition, or it should check the same condition. Yep. 1, 2, 3 is false, right? What is next? Okay, maybe we can do some printing in here. No, let's not. Let's go to the next one. Okay, so write a function with the following. We did that one. Write a function with the following signature. Returns true only when C's is comprised of vowels. Right, so only vowels, verbic is false, right? Because I have one vowel in my last name. It's very close though. Only vowels, E-U-O-U-A-E is true. That's actually a valid English word, by the way.
What is?
E-U-O-U-A-E. I don't know. It's an abbreviation used in Latin to show the distributions of syllables in differential, or I don't know. It's a word. I typed in longest word comprised of vowels into Google, and that's what it gave me. Right, so get out of my class. Right. Okay, so let's write this definition. Contains only vowels. Right, contains only vowels. Was that the signature that I gave it? Only vowels. Okay, get rid of this contains. Who needs this? Right. So C's, that is a list of characters. This is a string. I want to return from this a bool. Checks for all C in C's. That C is a vowel, right? So this mathematical notation that I introduced, already getting a lot of longevity from it. Only vowels on my last name is false. Only vowels, I can't remember that. Yeah, but yes. Wait, E-I-E-I-O. Okay. True. Old MacDonald. Okay. Okay, so how can we do this? What do we have to do? Okay, so we're going to have to check every individual letter in the string, and what are we checking for? So if C is not in vowels, which I'll now go up and write. Actually, I don't have to. If C is not in A, E, I, O, U, right, then what do I do? If C is not a vowel, right? Right, so if I find a C that's not a vowel, I can return false immediately, right? So reading over the Piazza, it seems that there is a misunderstanding, or at least, okay, I don't know how else to describe this. When you're checking that something satisfies a property, you don't check that it doesn't satisfy the infinite amount of things that don't. This is specifically about is-digits, right? You don't check that the number looks like this and that's not a digit. You don't say, oh, there's a letter in here, so it's not a digit. There's this in here, so it's not a digit. You have a pattern which is the only pattern that allows digits, and everything else outside of that pattern you can call false, right? So when checking a condition, right, if you want to check if some object has some property, you just need to figure out what that property is and check that property, and if it doesn't satisfy it, then you return false. Right? Don't start checking that it's not a number in the 100 different ways that it can't be a number. Right? So that's what we're sort of doing in here. Right? As soon as something violates a single property, you can return false. Right? So this should work. Let's see. Is not in. How come that's not valid syntax? Well, maybe I need some brackets. Oh. No. I don't know why I wrote is. If C not in, I was trying to be too close to English. Okay, perfect. Only vowels. E-I-E-I-O. True. Only vowels. Verbic. Only vowels. Verbic. False. Only vowels. Pow. Right, so we got to make sure that we actually are capturing all the cases that should be captured. Right, so I should actually add to this A, E, I, O, U. Because I never specified anything about the nature of the input. Right? I just said vowels. Right, so both a lowercase and an uppercase are technically vowels. So just be careful about these type of edge cases. All right, so let's try that again. That's better. Right, so just think, are there any cases that I missed that should be included? Not what are the cases that I should be excluding in order to find the cases that are included. This is a question from the final from 2016. It's question 3. Question 3 from final 2016 is asking you to check if a password is valid. And in this case, a password is a valid password when the password has exactly 8 characters and contains at least one uppercase character, lowercase character, digit, and a special character among bash, hash, %, and asterisk. Okay, so let's do this. This is a good question, right? And one that's on your file. I'm trying to train you guys to pass your final. Oh, write code on paper, right? For practice. When your midterm comes and your final comes, you're not going to have access to a computer. You need to already be comfortable writing code down on pen and paper. So what I recommend to you is when you're in the labs or practicing at home, write your code on paper first and then type it into your compiler, right? Just so you can get used to programming on paper, which has double utility, right? That's how you're going to be tested here at the University of Toronto. And companies like Facebook, Google, Twitter, that's how they interview you, right? They say, here's a problem, here's a piece of chalk, go to the board and write down your solution. They don't say, here's a computer program, right? So this is preparing you for academics and industry, right? So really follow my advice and you'll go far, kid. Okay. I just want you guys to do well and get good jobs. Right? That would make me very happy. If one of you became the new head of Google and were like, oh, I remember the day that I wanted to become the head of Google. Right? October 3rd. My professor was talking about strings. Right? Okay, so checks. If password is a valid password, using criteria from slide 6, right? So how can I get a valid password? So it has to be 8 digits. 1, 2, 3, 4, 5, 6, 7, 8. Has to include at least one special character, has to include at least one lowercase character and an uppercase character. Is that it? And a digit. Okay, so that should be okay. And this should be false. Right? How can we do this? Or how would you attack this on your final? Right? We have to check 5 conditions, right? So why don't we just check 5 conditions? Yeah.
Maybe go for like the first condition, like make sure that it's 8 characters.
Sure. First condition, right? Check. Well, okay. This is an instance where the actual code is more descriptive than whatever a comment I can write. So I can say if the length of password is not equal to 8, return false. Right? So that's the first check, right? And again, I'm showing you if it fails one instance, then you can automatically return. Right? We're done. If it's not equal to 8 characters long, satisfying the rest of the conditions is meaningless. It needs to satisfy all of them. Okay, what's the next condition we have to check? Contains at least one uppercase character. Okay. 4. So how can I check that it contains at least one uppercase character? Yeah, determining if a single character falls into a range is no problem, right? But communicating I found one, you can continue, right? Okay, so I'm going to show you, because I would have liked to do it in such a way where I'm just testing for the violation of conditions, but that ends up actually being pretty messy. So as you see, we have 5 conditions here. We've already checked condition 1, right? I'm going to create some names. Condition 2, condition 3, condition 4, condition 5. And I'm going to assume at the moment that they're all false. Okay, then I'm going to walk through my string for P in the password, or maybe for a character in the password. What do I have to check? Contains at least one uppercase letter. Okay, so if C is an uppercase letter, so how can I test if it's an uppercase letter? So if C is less than or equal to Z, but greater than or equal to A, right? This means C is uppercase, which means the condition 2 is true, right? Similarly, if C, and it's not an else, right? Because I want to check all of these conditions, right? Nest the ifs? Yeah, you can check that each condition is satisfied, but then we'd have to nest like 5 times. And I'm trying to avoid that. But that would be correct. We could also just write one giant if statement. Right? I could check everything as one huge if statement. But right now we're finding out that there's many ways of writing a program. Some of them will be ugly, some of them will be elegant. We're trying to trend towards elegance rather than ugliness. But you could sometimes get too elegant where that like nothing makes sense anymore. That like you wrote the most beautiful one-line program that only you understand how it works. That's also not very ideal. So we're trying to strike a balance. Okay, so C is lowercase if it's between Z and A. And in this case, I can set condition 3 to true. If C falls in between 0 and 9, right, then C is a digit, which means the 4th one is true. And if C is in these special characters, nope, no $, or asterisks, then C5 is true, right? And then here I return C2 and C3 and C4 and C5, right? So maybe I can make this a little bit more clear if I just, yep.
For the length of the password, if we say not equal to 8, does that mean that anything that's above 8 will also not be correct?
Is 10 equal to 8? So is 10 not equal to 8? Yes, so
What about everything beneath it?
is 6 equal to 8? Is
Do
6?
we want it exact?
Yeah, it says it has to be exactly 8 characters. Yeah, but that would be a simple change, right? If we want it to be at most 8 characters, then I would just have to modify this condition a little bit. So Right, so let's give this a try. So what did I do? I first checked that if it was 8 characters or not, and if it wasn't 8 characters, I ended immediately. Provided that it's 8 characters, now I want to look at those 8 characters, and I'm checking, so this is called like a toggle, or a switch. I'm saying all the switches are false. And as you walk through this string, if you find something that satisfies one of these conditions, switch it to on. And then at the end of my algorithm, I'm going to see if all the switches have been toggled to on. And if they're all on, then we're good. Right, so when I can express as a mathematical statement, that's return. This will return true only when C2 is true, and C3 is true, and C4 is true, and C5 is true. Right? So just imagine that. We're walking through the string and switching stuff on as we're walking through it. So exit. Let's call this in. Let's call valid password on Verbic. I guess that will be false. On 1, 2, 3, 4, 5, 6, 7, 8, that will also be false. If I add a special character, a lowercase character, and an uppercase character, that should be true. Right? So let's try printing stuff. What did we find here? We found C. So found uppercase. Here we found a lowercase. Here we found digit. And here we found special character. And if I run that through, you can see how this operates. Okay, so it's walking through the password. And at position 1, it found a digit. At position 2, it found a digit. At position 3, it found an uppercase character. At position 4, a digit. Position 5, a digit. Position 6, a lowercase character. 7, a digit. And 8, a special case character. Right? So each time it found something, it switched it to true. If it found it again, it doesn't care. It gets set to more true. Right? But this is how the loop is working. It's iterating its way through the strings and saying, is this something, is this something, is this something? Right? So this is a structured way of solving a problem like this. This would have been a significant, I think this is already like a significant proportion of the exam. And this is a full, I think maybe 5 marks or something. Anyways, so you should be able to do this, right? Because it was on the exam 2 years ago. Write a function with the following signature. This is a fun one. Oh, I made the signature wrong. Wow, I was getting a little bit lazy. Or distracted maybe. Okay, so ignore. Well, anyways, I want to write a function with the following signature. I'll correct this before I put it on the website. That you accept a string of characters, and I want to repeat each of those characters k times, right? So if I want to repeat the character on Verbic twice, that is VVRRBBIIKK. And if I want to repeat characters on Hello World with 2, that would be HHEELLLLOO, right? And this should work with any Unicode character, right? When I say characters, don't think like alphas, right? So we have alphas, digits, and characters include things like smiley face and, 100 with double underline, stuff like that. Okay, so repeat characters. What time do we got? Half past. Repeat. Good, you can see that. Characters. I'm going to take a string, and I'm going to return a string. Now I also need to accept a k, which is an integer, for the repeats. Returns a new string with each character repeated k times in order. All right, something like repeat characters on hello world. Maybe I'll do a 3. This should be 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Spaces are a character that need to be repeated. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, what about this? Guys, I want you to think about the correct base cases here. What does it mean to take a string and to repeat every character 0 times? So this will be what? Empty string, right? It's also a good edge case. Okay, so clearly I want to accumulate something. So there's a value to accumulate. I want to walk through my string, and then I eventually want to return my answer. So what do I want to accumulate here? Well, I want to accumulate something into answer. But what? So I'll show you a little hint here. What? Bruh. 3 times A. 10 times AA. 10 times Paul. And you can multiply strings, and it repeats it. And so given that, what am I accumulating here? I heard someone say it, yeah. K times C, right? And I'm just going to print what it's accumulating, okay? Repeat characters in hello world. Oh, I need to give it a thing. Right, so that's how it was accumulating. Maybe I should do a smaller example. Right, so it's walking through the string, it's looking at capital H, and it's saying, okay, accumulate this, but twice. Then it walks to the second thing, it says accumulate 2 E's, now accumulate 2 L's, now accumulate another 2 L's, now accumulate 2 O's. It's just walking and repeating in that manner. Let's see what happens if we give a 0. Ah, yes, it's accumulating an empty thing at every line. So that's good, right? I guess the whole point of this question would have been this, right? If this was worth 5 marks in your exam, that edge case probably would have been worth 1, right? Because finding that edge case is hard. So think about, it's not necessarily the case that if I give you an empty input that you should return like error, right? In this case, 0 actually makes sense, right, in terms of the definition. So in other cases, things will make sense, right? Given the empty list, we've asked you to do something. Like, so if we say sort the empty list, you don't say, I can't sort the empty list. You say, here's the empty list. It's sorted, right? So, but we'll get to that when we get to that. How much time do we got left? We have a lot of time. Oh my God. Bruh, is this one fun? Let's do this one instead. Okay, so this is from the final 2016 question 1. Right, so the very first thing out of the gate. Write a function, zigzag zip, which takes 2 strings and returns a string. We're going to make an assumption that the strings are the same length. And what do I want to do? Well, I want to create a new string where I take the first character from the first string, the second character from the second string, the third character from the first string, and I alternate in that manner. Right, so zigzag zig. On these 2 strings, we'll go A, then 1, A, then 2, then C, and zigzag zig on A, B, C, D, 1, 2, 3, 4 would go A, then 1, A, then 2, then C, then 4. And I hope you see what we're doing. Okay. So let's see what we can do. Def zigzag zig takes a string. Oh, takes 2 strings. String 1, string 2. They're both strings. Maybe I'll just get rid of that. String, and I'm returning a string. Zigzags through 2 strings, as in slide 9. 1, 2, 3, zig, zag, zig on ABC. 1, 2, 3 should be A to C. And I won't write the other one. Okay, any ideas? So clearly we need to accumulate something. And I'm going to return that, but what should we do in the interim? Yeah. We need to use a for loop, but what am I looping through? Okay, so for character in string 1. And then, okay. How's that going to help? So what we need to do is we need to walk through both strings individually. And then the second thing we have to do is indicate which one we want to accumulate from. Yeah.
Maybe we have a counter that starts at 0, adds 1, and whenever the counter is paused, then print out the string.
Exactly, yeah. So remember that when we have strings, don't forget that we can index them, right? And in fact, we can also slice them. Right? And we can also take their length. Okay. So what I'm going to do is I'm going to create a counter and start it from 0. Or maybe I won't call this counter, I'll call this the position we're currently at. Right? So notice if I increment the position here, let's compare C, right, this C, with the position on string 1 and the position on string 2. Right, on your exam, this should be a lot easier to write because there's you have something called range, but we don't have that yet. So I'm just going to show you how to do it with our tool set. Okay, so this isn't solving anything yet. This is just sort of exploratory programming. So zigzag zig on ABC 1, 2, 3. Okay, so it's saying the compiler is saying I've walked to A in the first string, which is position. Okay, I should do this. Try it again. Okay, so the compiler said, look, in the first string I'm at A, which happens to be at index 0, and the thing at index 0 in string 1 is A, and string 2 is 1. I'm going to walk to B, which is at index 1, and at index 1 on string 1 we get B, and on index 1 on string 2 we get 2. Right, so it's walking through the strings and it's carrying an index with it. Okay, so given that we have the index in position, if C, so we need to go back and forth, right? So the way to do that is by remaindering by 2, right? So if C, I need chalk. Okay, we have 2 lists here. I'm going to call it string naught and string 1. Right? They're both the same length. They both have the same indexes, right? So this is I and this is I in here. I need to somehow toggle between these 2 lists, right? So notice what happens when I count remainder 2. If the index, right, and this is the value mod 2, right? If the index is 0, mod 2, you get 0. If it's 1, you get 1. If it's 2, you get 0. If it's 3, you get 1, and so on. See how this is alternating between 0 and 1? Right? So we can use that to tell us which one to accumulate by. Right, so if C mod 2 is 0, then I want to accumulate on the first thing. Right? String 1 at count at this position, and else I want to accumulate on the second thing, string 2 at this position. And notice how I have to increment the position last, because I do want to look at the 0th character. All right, so after I look at the 0th character, then it's okay to increment the position. Let's see if this works. Oh, C is not a number, but position is a number. One B C, 1B3, perfect. Okay, let's try this. 1, 2, 3, 4, 5, A, B, C, D, E. Great. And this should break. Yeah, right, because it violated our input assumption. So that's one way of doing it. I can show you a little trick if you want. There is something in Python called the enumerator. So I can do something like this. For x in, okay, I could say for x in this string, right? Just basically print x, right? And it will do that. I can also say for some index and x in enumerate A, B, C, D, E. Print the index and x, right? So there's a way of actually walking through a group and having a counting variable created for you. Right, so to enumerate something is to go step by step through something and count. Right, so I could have said could simplify this by saying for position and C in enumerate S1. I can get rid of this. And I can also get rid of this. And that should still work. Ah, A, B, C, D, E, F. Nope. E. Nope. Oh, now I put power. Perfect. Right? So that's one little simplification that you can perform. 15 minutes. Okay. Write a function to check if a string is a palindrome. This is a favorite type of question among tech companies. Right? It's actually not that easy to efficiently check if something's a palindrome. But we don't really care about efficiency at the moment. We just care about being able to write any code that's correct. So this is super easy. If I put this on your exam, I want you guys to cheer if this is so easy. How can I do this with one line using stuff that you've learned already?
Where you flip the word and see if it's the exact same as the string you start out with.
That's it.
But doesn't have to return a bool?
This will return a bool.
But you wrote arrow string.
Oh, sorry. Thank you. Thank you. Yeah. Very easy, right? One line. Let's see if it works. Whoops, that's not the one I want. Race car. Rack. Let's see if I can remember this. Ere was I as I saw Elba. No, Abel was I. No. No. There. Abel was I ere saw Elba. Do you guys know that? You guys know what this is? This is a famous palindrome that was uttered by Napoleon as he was exiled to the island of Elba. And it just happens to be a palindrome, that sentence, right?
But didn't Napoleon speak French?
Yeah, details, right? That ruins my story, right? It's also a French palindrome. Okay, so that one was easy. How can we do it better? How can we do it in such a way that we're not... Because like, you have to imagine now I gave you a string that's 1 billion characters long. Huge. Maybe I give you a string that like occupies 10 gigabytes of data on your hard drive. And I'm like, is this a palindrome? So the steps that this is taking is, okay, give me your string. I'll create another one and reverse it. It's like, oh, okay, your first act is to double the occupation of memory of this program. Right? That's bad. Right? So what would be a better way of doing this so that we don't have to create a duplicate string?
Maybe take half of it. Oh, actually,
You gave up instantly. He's like, oh! For shame. So remember, right, we have a string. We can look at its first character and we can look at its last character, right? And we can look at its second character and we can look at its second last character. And we can keep moving in, right? And if we find that as we move in, 2 positions are not equal, we can return it failed immediately. Right? So this won't speed up trying to find if something is a palindrome. We'll have to look at every character. But suppose this was 1 billion units long, and the first thing is not the same as the last thing. Well, then you just save a ton of time. Right? So let's try writing that. Okay, so for the position and the character in enumerate C's, what do I want to do? I want to check if C's at this position, we're going to have some index slicing problems. And it's going to be the position -1, right? If position is 0, you want to check 0 and -1. If position is 1, you want to check, oh no, this is wrong. Is it 1 minus position? Well, I don't want to use length minus 1 because I want to use the negative indexing. Right, so if this is position minus 1. No, it should be minus position plus 1. Right, 1 minus position. Okay. No, that's not right. My God, somebody help me, right? Okay, so we can figure it out this way. I need to do this. I need 0 and minus 1, 1 and minus 2, 3 and minus 3.
Yeah,
Right.
Why couldn't you do length then?
Huh?
Why couldn't you do length minus position?
Because I want to use the negative indexing, right? Using the length this is more Pythonic. We can figure it out. This seems to be, if this is position, this seems to be position minus 1. Or minus position minus 1. That's right, okay. See, I showed you how to work stuff out when you're troubled, right? You can think through it. Think through it. Minus position minus 1. Perfect. Okay, so now I want to check if these two positions are not equal, then I want to return true. False. And if I make it through the whole string and never trigger that return, then I want to return true. All right, so let's check if this works. True. And I'm just going to change this to a 1. False. And determine that in 1 step, not 8. All right, so there's 2 ways of writing the same thing. This is a little bit better. Right? One more? Yeah, one more? Let's pick one, though. Okay, so I have... There's 3 more. And you can choose... No, there's 2 more, and you can choose which one you want. One of them I'll do, the other one you can do. So write a function that takes as input C's and a character C and returns the rightmost position of C in C's. And if that position doesn't exist, then it returns -1. Do not use the built-in find command. Okay. Other option. This is the question 4.A from exam from last year. Complete the body of the following function. Separate and reverse. So you give me a string and I return 2 strings back. The first string are all the vowels I found listed in reverse order. And the second string are all of the non-vowels I found listed in the proper order. Right? So Catherine wants to go to the zoo. Reading backwards, that would be O, O, E, O, 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 A, and so on. And then reading forwards, I would just dump the vowels. And of course, if you want to separate and reverse on something that doesn't include characters or vowels, you get an empty string and then a full string back. So in the last 10 minutes, which one do you want me to do? Any takers? Or do you just want to go? Are you guys tired? Speed run both? All right, let's speed run both. We can totally do this. Okay, so okay. Find position in C's string. I want to find C in this, and I want to return the integer where I found it. Find rightmost position of C in C's. Okay. So what do I want to do? I want to run backwards through the string. So for position in C in enumerate this, if blah blah blah. I'm going to use a candidate. So max position is currently at -infinity. Right? It doesn't exist yet, right? Or actually, I don't even need... I'll say that the max position's at index -1, which doesn't exist. Okay? Okay. For position in C in this, if C is equal... Oh, I can't use that C. I'll use D. Right? If D is equal to C, if this is the character I'm looking for, and the position is greater than my max position, right? Then max position gets position, right? Else I continue. And then when I make it through the whole list, I return max position, and that should work. Okay. Find position. In ABC, I want to find C. That should return 2. Oh. 2. Okay. Find position E in that. That should return -1. Great. If I put multiple C's in here, it should return the last one. 12th position. What is at the 12th position? E. Perfect. The rightmost D. Okay, so that one's done. Boom. Okay, next one. Returns 2 strings. Got it. Okay. Definition, separate and reverse. It takes C's string and returns a string. This is going to return 2 strings according to slide 12. And then, all right, I'm going to leave out the doc string because I'm speed running this. Okay, 4 minutes, 4 minutes. I need to accumulate 2 things. So I have the answer for the vowels, and I have the answer for the not vowels. Other. Right? So they both start at empty. Okay. I'm going to walk through my string for C and C's. If C is a vowel, A, E, I, O, U, or the capital versions of that, don't forget about capitals. Capitals are vowels as well. Then I want to accumulate on vowels. Else, I want to accumulate on other. And actually, I'm going to accumulate on the other side, right? So it comes in reverse as we want it. And then I'm going to return both of these, right? Return answer vowel, answer other. And let's see if this works. I'll be stoked. Separate and reverse. We have Catherine wants to go to the zoo. Okay, Catherine wants to go to the zoo.
We can't see the side.
Brah. Just to prove that it works, right? Perfect. All right, I did it in 6 minutes. Go, go, go. You're not supposed to clap. I'm not entertainment, right? Are you not entertained? Right.